Good morning to all. I am Uttammal, Assistant Professor, Department of Mathematics, Rogini College of Engineering and Technology. Today I am going to explain the topic Bilinear Transformation. Course code MA8251, course name Engineering Mathematics. Course outcome. After completing this topic, the students will be able to know digital signal processing and discrete time control theory to transform continuous time system representations to discrete time and vice versa. Bilinear transformation. The transformation W is equal to AZ plus B divided by CZ plus D when AD minus BC not equal to 0, where A, B, C and D are complex numbers is called a bilinear transformation. Now the formula for bilinear transformation. The bilinear transformation which transforms Z1, Z2, Z3 into W1, W2, W3 is W minus W1 into W2 minus W3 divided by W minus W3 into W2 minus W1 is equal to Z minus Z1 into Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1. Now problems based on bilinear transformation. Determine the bilinear transformation that maps the points minus 1, 0, 1 in the Z plane onto the points 0, I, 3I in the W plane. Solution. Now the points in the Z plane are denoted by Z1, Z2, Z3 and in the W plane are denoted by W1, W2, W3. Here the points in the Z plane are Z1 is equal to minus 1, Z2 is equal to 0 and Z3 is equal to 1. And in the W plane, W1 is equal to 0, W2 is equal to I and W3 is equal to 3I. Now write the formula. So the formula for bilinear transformation is W minus W1 into W2 minus W3 divided by W minus W3 into W2 minus W1 is equal to Z minus Z1 into Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1. Now substitute the points W1, W2, W3 in the left hand side and Z1, Z2, Z3 in the right hand side. We get W minus W1. So here W1 is 0 into W2 minus W3. So W2 is I minus W3 is 3I divided by W minus W3. W3 is 3I into W2 minus W1. So here W2 is I minus W1 is 0 is equal to, in the right hand side, Z minus Z1. So here Z1 is minus 1. So we have to write in bracket into Z2 minus Z3. Here Z2 is 0 minus Z3 is 1 divided by Z minus Z3. Z3 is 1 into Z2. Z2 is 0 minus Z1 is minus 1. We have to write in bracket. So minus 1. Simplify. We get in the left hand side W minus 0 is W. I minus 3I is minus 2I divided by the denominator W minus 3I into I minus 0 is I. In the right hand side simplify. Z minus of minus 1 is Z plus 1 into 0 minus 1 is minus 1 divided by Z minus 1 into 0 minus of minus 1 is plus 1. Now here in the left hand side contains minus sign and in the right hand side having minus sign, so we can cancel it, and in the left hand side the numerator having I and also in the denominator having I, so we can cancel it. So now simplify. We get 2W is equal to W minus 3I in the right hand side Z plus 1 divided by Z minus 1. Now that is 2w divided by w minus 3I is equal to z plus 1 divided by z minus 1. Now by cross multiplication, so we get 2w into z minus 1 is equal to, in the right hand side, z plus 1 into w minus 3I. So now simplify, we get in the left hand side 2w into z is 2wz minus 2w into 1, that is minus 2w, is equal to, in the right hand side, z into w is wz plus 1 into w is w. Now minus 3I into z is minus 3zi and 1 into minus 3I is minus 3I. Now keeping the real term into the left hand side and imaginary term into the right hand side, then we get 2wz minus 2w minus wz minus w is equal to minus 3zi minus 3I. Now in the right hand side, find the common factor. So here minus 3I is the common factor. So we take out minus 3I, the whole into, now the remaining factor in the first term is plus z, in the second term is plus 1. Now in the right hand side, the common factor is w, so take out w into, right, the remaining factor in the first term is 2z minus, in the second term is 2, and in the third term is minus z, and in the last term is minus 1. Now again simplify. So this is w into 2z minus z is plus z, and minus 2 minus 1 is minus 3 is equal to, no change in the right hand side, that is minus 3I into z plus 1. Therefore w is equal to minus 3I into z plus 1 divided by, keeping the left hand side factor z minus 3 into the right hand side. So this is z minus 3 in the left hand side is in product form, so we have to write in the division form. Therefore the answer is w is equal to minus 3I into z plus 1 divided by z minus 3. Now the second problem, find the bilinear transformation that maps the points z is equal to 0, minus 1, I into the points w is equal to 0, I, 0, infinity respectively. Solution. Now the points in the z plane are denoted by z1, z2 and z3, and in the w plane are denoted by w1, w2 and w3. Here the points in the z plane are z1 is equal to 0, z2 is equal to minus 1 and z3 is equal to I. In the w plane are w1 is equal to I, w2 is equal to 0 and w3 is equal to infinity. Now write the formula for bilinear transformation, that is w minus w1 into w2 minus w3 divided by w minus w3 into w2 minus w1 is equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. So here in the w plane, the point w3 is equal to infinity. When substitute w3 is equal to infinity in the left hand side, so we will get infinity. So for avoiding this, omitting the factors involving w3. So far in the left hand side, we have to omit the factors w2 minus w3 in the numerator and w minus w3 in the denominator. Now we have to write the remaining factors in the left hand side. We get w minus w1 divided by w2 minus w1 is equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. Now substitute the points w1, w2 and z1, z2, z3. We get w minus, here w1 is I divided by w2 minus w1, here w2 is 0 minus w1 is I is equal to, the right hand side z minus z1, z1 is 0 into z2 minus z3. Here z2 is minus 1 minus z3 is I divided by z minus z3. Here z3 is I into z2 minus z1. So here z2 is minus 1 minus z1 is 0. Now simplify, we get w minus I divided by minus I is equal to z divided by z minus I into 1 plus I. Now by cross multiplication, so we get w minus I is, now keeping this minus I into the right hand side, so we get z divided by z minus I into 1 plus I into minus I, then we get z divided by z minus I. Multiplying these two factors, we get 1 into minus I is minus I and plus I into minus I is minus I square. We know that minus I square is equal to 1. So now I square is equal to minus 1. So now minus into minus 1 is equal to plus 1. So minus of minus 1 is plus 1. So that is w is equal to, now keeping this minus I into the right hand side, so minus I goes to plus I in the right hand side. Now that is in the first term, multiplying by this z, so z minus I into minus I z plus z into plus 1 is plus z. Now by taking LCM, so for the second term can be written as I into z minus I, the whole divided by z minus I. So the answer is for the second term I into z, I z. Now I into minus I is minus I square. The value of I square is minus 1. Minus into minus 1 is plus 1. So now minus I z plus I z will be 0. We get z plus 1 divided by z minus I is equal to w. Now the last problem, find the bilinear transformation which maps the points 1 I minus 1 onto the points is 0, 1, infinity. Solution. So now the points 1 I minus 1 are in the z plane. So the points are denoted by z1 is equal to 1 and z2 is equal to I and z3 is equal to minus 1, and the points 0, 1, infinity are in the w plane. So we have to write w1 is equal to 0, w2 is equal to 1 and w3 is equal to infinity. Now write the formula for bilinear transformation. So the formula is w minus w1 into w2 minus w3 divided by w minus w3 into w2 minus w1 is equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. So for here the point w3 is equal to infinity. So we have to omit the factors involving w3. So we have to eliminate the factor w2 minus w3 in the numerator and w minus w3 in the denominator. So we get w minus w1 divided by w2 minus w1 is equal to z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1. Now substituting the points w1, w2 in the left hand side and z1, z2, z3 in the right hand side, we get w minus 0 divided by 1 minus 0 is equal to z minus 1 into I plus 1 divided by z plus 1 into I minus 1. Simplify, we get w is equal to z minus 1 into I plus 1 divided by z plus 1 into I minus 1. So for here separately we have to find the value for I plus 1 divided by I minus 1. So we have to using its conjugate. So multiplying and dividing by its conjugate. So the conjugate of I minus 1 is I plus 1 divided by I plus 1. So now simplify. So multiplying the numerator we get I into I square plus 1 into I again plus 1 into I plus 1 into 1 divided by Now the denominator is of the form a minus b into a plus b is equal to a square minus b square. So here a is I and b is plus 1. So that is I square minus 1 square. So now here I square is minus 1. So minus 1 plus 1 will be 0. So plus I is 2I divided by the value for I square is minus 1 minus 1 square is 1. So minus 2. So now 2 cancel. So that is equal to minus I. Now substitute I plus 1 divided by I minus 1 is equal to minus I. So therefore W is equal to, now multiplying by this minus I, we get Z into minus I is minus I into Z, minus 1 into minus I is plus I divided by the denominator Z plus 1. So therefore the answer for W is equal to minus I Z plus I divided by Z plus 1. Now some important questions in this topic. Thank you.